we have been discussing how these area formula relate to each other to form an axiomatic system. Where the square is assumed to be true, it's the axiom is side squared. We were able to use that to prove that a rectangle is base times height. And then based on the rectangle, we were able to show that the parallelogram was also base times height. And then based on the parallelogram, the triangle is a half of base times height. And notice that the triangle traces itself all the way back to the square because the triangle is based on the parallelogram, which is based on the rectangle, which is based on the square. Next up is the trapezoid. Okay, so we have these same series of shapes here, and so here is a diagram of a trapezoid. And it's drawn on a piece of graph paper so that we can really visualize what's going on here. Now, one of the things that you might think that we could do is sort of what we did for the parallelogram, that we could take this right triangle and then slide it over here. We could translate it over. But does this right triangle fit in this little tidy spot? No, it just doesn't, right? This is 1 by 4, and over here this is 3 by 4. That does not fit, right? It wouldn't line up. Okay, so we have to do it some other kind of way. And the other way that we're going to do it is like we did with the triangle. So for the triangle, we had to double up our shape. We had to make another copy of it. We basically rotated it around the center point right there to make 2 copies, and that made it a parallelogram. And then in order to get back to the original blue shape there, we had to take half of it. Hey, wait a minute. Doesn't the trapezoid area formula also have a 1/2 in it? It sure does. Okay, so that gives a hint as to what we're going to do. We're going to do the same kind of thing that we did over here. We're going to duplicate this trapezoid and rotate it around so it fits right over here. So see if you can visualize that. What's that going to look like? What shape is that going to make? And you can see that it makes a parallelogram. And when I double it up, you can see that this base 2 down here is the same thing as this one up here. Base 1 is the same thing as this base down here. So let's see if we can do a little bit of algebra on this to come up with what that trapezoid area formula is supposed to be. So we can see that this thing is definitely a parallelogram. Okay, and a parallelogram's area formula is supposed to be base times height. So I want to see from this parallelogram, what's my base length and what's my height? So my base length is supposed to be this whole entire length that's right down here. So notice I have a B2 for this section of it, and then I have a B1 for the other part of it because it came from up here, and so that just rotated down here. So the whole entire thing is just the sum of those 2 pieces. It's a base 1 plus base 2. That sounds familiar. Base 1 plus base 2. All right, and then we need our height, and the height is the height, right? It's this thing here, which is marked in red for us, either there or there. There's our 2 pieces of information. So as a parallelogram, its area formula is the base length, base 1 plus base 2, times the height, times h. That's the whole entire picture. So what do I do to this area formula so that I can go back to only having just this trapezoid, just one of these things? Well, I doubled the shape up, so to go back to the original one, I am going to take half of it. I'm just going to divide it by 2. So there you have the trapezoid area formula. And we can see that that one is based on the parallelogram, and the parallelogram was based on a rectangle, and then the rectangle, of course, was based off of the square.